Hello students, this is a class of control system. You all know that control system is a very important paper for electrical, electronics and the ECE students. So in this lecture, I will be discussing about the introduction to control system. We will start from the basics. So let us first understand what is actually a system, because in the name of control system there are two terms, one is control and another is system. So first we need to understand what is a system, and then control system, and then what are its basic components. So now what is basically a system? From the name system, you all know from the literary name of the system that system is a combination of some components, and those components when are combined together, if they are interrelated with or mutually related with some relation, then they can, and if in that process they can perform some specific task to fulfill some desired objective, then we can say that this that is a system. Means the all the components is comprising a system. So this is the basic definition of system. Now let us attach the term control to the system so that the whole thing becomes control system. So what does it mean when we append that term control to the term system? It is basically when we are forming a system in that manner, which I have right now discussed. If we apply some control objective into the system, that control objective for various means to fulfill a desired purpose, then the whole term control system comes. So let us now move on to some basic real life examples. It will be better for us to understand the thing control system if we start taking some of the examples from the real life. Let us see some examples, very basic, very common examples for you. One is regulation of temperature and humidity of a room or a building. Let us suppose we want to measure and maintain the temperature or humidity of a particular room or a particular building at some predefined specific value. Now, if by some means, by extraneous factors or some other because of some other things, if that value changes, means if it alters, then the work of the control system, if we can define, we are able to define the maintenance of temperature and humidity of a room is our objective, is our control objective. We can fulfill that objective by applying some controlling principle in the system of maintaining. That means in system is maintaining of the two parameters of the room. One is temperature and another is humidity. So from this example you can understand that both the term control and the other term system is associated with each other. That means we are controlling in some ways the temperature and humidity, which are the two parameters of a system. So it is a real life example of control system. Let us take another example, transportation of vehicles. We all know when we used to drive a vehicle, when we used to travel in a vehicle, then we always want that we should be reaching our destination in an accurate manner. That means we will try to reach the accurate destination and in a safest way. So that is the transportation of vehicle. How it can be possible to reach the accurate destination in a safest way? We need some control mechanism to be applied on the system, which is vehicle here, that will be carrying us to the proper destination what we want and in a safest manner. So that is also a real life example. Another real life example is the product manufacturing. In the industry, you all know, in the manufacturing industry, they are specifically dealing with some products, preparation or manufacturing of some products. Now, every organization who are into the manufacturing, they always want the quality, that means assurance of quality and the yield of production and the costing. Now, to maintain a proper check and balance between these three parameters, this product manufacturing can be called as a very good real life example of control system. That means we will always apply some control criteria so that our production yield will be higher with lesser cost, and also the quality will not be compromised. So this is another very good example of control system, real life example. Now running a marathon, this is another one. You all know in a marathon race, when the athletes, when the runners used to run the marathon, they used to complete the whole range in a very, very long time. So because the range of the marathon, the run of the marathon, it is maybe 1000 meter, 10,000 meter or even more. So for that long run, athletes need to preserve their energy to the highest level. You all know. So what is the control objective? Now who is the system in this example? System is an athlete or a runner. And we need to apply some control criteria, control mechanism to maintain, to preserve his or her energy who is running the marathon. So this is another example of real life example of control system. So these are the very primary examples what we can pick from the nature, and we can explain with the concepts of control system that these are the very good examples. Now let us move on to a block diagram. This block diagram is nothing but this connected diagram. This is called the block diagram. This is the basic way of representation of a system applied with some control objective. Now let us see this diagram. Let us see this example. This is the example of automobile drive system. It is written over here. What in the diagram it has been shown? It has been shown there are two blocks. These are called blocks, and in these blocks, inside the block, two terms are written. Here it is written accelerator linkage and carburetor. Since it is an automobile drive system, these components, accelerator linkage and carburetor, are the very essential parts of any automobile drive system, and another is engine vehicle. So these are the parts of the system which has been defined here as automobile drive system. Now these two parts are internally connected. So this completes the whole way of representing the control system in block diagrammatic form. In the next lectures, I will be far more explaining elaborately what is actually meant by this block diagrammatic representation for any control system. Now in this first block, we have applied with a force. This force is coming from the external side, from the external world this force is coming. That means the driver who is driving that automobile is applying with his legs some forces on the accelerator pedal. So when he applies his forces on the accelerator pedal as a function of that accelerator position, here you can see as a function of that accelerator position based on the applied force by the driver's legs, then accordingly the speed it is being generated in the vehicle. So speed is a function of accelerator position, and this is directly in proportion to the applied force by the driver. Now this force which is being developed, developed from outside and going into the system to make the vehicle run is happening in this way, that this accelerator position will just control a valve which is called carburetor valve, which will be opening and closing in a random manner, whatever be the requirement of the output. According to that, the valve will be opening and closing in a random manner, and accordingly it will control the rate of flow of fuel into the engine of the vehicle. So this is the whole process. This is the actual control process happening in the automobile drive system, where this external force applied by the driver's legs is going into the system, and where these two blocks, which are the essential components of automobile drive system, this accelerator linkage and carburetor and engine vehicle, they are internally connected with a particular signal flow. This signal flow is unidirectional. It is flowing from the carburetor side into the vehicle, not in the reverse direction. So this signal flow is unidirectional. This signal flow, this rate of fuel flow, is termed here as a signal. I will explain in the next classes how when I will be going into the mathematical modeling of a system, how all these terms will be represented as a mathematical function or mathematical parameter. So this rate of fuel flow, this will be turned here primarily as a signal, and that signal being given to the engine vehicle. So engine vehicle will know how much fuel is coming from the opening or closing of the carburetor valve, and accordingly you can see in the output the speed is being generated. So therefore we can say in this example of automobile drive system, the external force is being converted into speed. That means it is going through a unidirectional signal flow through this whole system, and finally the speed will be a function of accelerator position, and that accelerator position is directly proportional to the force applied by the driver. So this is the automobile drive system. Now let us move on. The last part of this lecture, that is the basic components. Now if we summarize the whole thing, now let us finally find out the basic components of any control system. What are the basic components? Number one is control objective. We need to specify, fix up a control objective. We need some system components to be interconnected to achieve that control objective, and finally the results which will show in front of us. So let us now have a basic, if we connect all these three basic components, let us have this diagram. You can see again, once again it is a block. The system is being represented as a block, and where these control objectives being applied, this is the control objectives being applied as its input or actuating signal. In the control system, this can be treated as input, or sometimes it is called actuating signal. That means, what is the meaning of actuation? Actuation means to make things happen with the application of signal. To make things happen with the application of this signal. So this actuating signal or the input is one component which will be generated from the control objectives, and it will go into this block, and this block is having the whole system, whole architecture of the system inside it. So inside this block we will just write system components. So inside this block we will just write system components. So if we now compare these two diagrams, this accelerator, from this example, this accelerator, linkage and carburetor and this engine vehicle is combining into a one single block, and that is being represented here as system components. That's why this diagram what we are developing here, this is basically the basic the control system block diagram, which is showing the three primary three primary components. So once this input or the actuating signal is going into the system components, it will generate the output or the results. In control system, sometimes this input you can see can be termed as excitation, or the actuating signal can be termed as the excitation which is being provided to the system. So a system having some components interconnected with each other, and getting that input, the system will generate the output which we will be sometimes calling in the control system as response. So these are much more better generic terms for system inputs and outputs as excitation and response respectively. So this is the basic control system block diagram, where the three components have been shown: the input or the excitation function, the system component, and the response or the output. So what is happening here? To fulfill a particular control objective that can be shown from the results, we can generate that from the system components. System components will work all together to fulfill that common objective. They will not work individually. It will not provide any such type of result which can fulfill the control objective. So they will act all together in a cohesive manner. They will be generating that output, and for generating that output, some inputs are required, which are the excitation into this system, and that excitation can come from any type of physical variables from outside the external world. So if we apply any type of physical variables or parameters as the input or excitation excitations from the external world into the system will work in a cohesive manner, not individually, not singly. They will be work in a cohesive manner, in a altogether in a common to fulfill that common objective that will be shown from the results. So this is the ultimate idea of why we should be studying control system and what is actually a control system. So that's all from today's class. Thank you for listening and watching.